Hey everybody, we're live in stereo. This is the third class of the day and we are on with more and more practice. I've promised you I will do the maximum number of questions any teacher has ever done with students in your entire life. These are papers from 2014 to 2024, all variants, all sessions, and these are all the questions of chapter number 1. Yes. And similarly, we will continue to do more and more questions. It is very important to take the booklet, everybody. Very important to purchase the booklet, because again, I say so, no proceeds are going to me of this booklet. It's totally up to you whether you want to take it or not. But see, don't waste your precious practicing grades instead just by saving 6,000 rupees or whatnot, So, without further ado, I think we did it till question number 25, if I'm not wrong. Did we do till question number 25 in the part 2? You do till question number 25. Anybody who took the first class, I think Laiba was there and Vanya was also there. I think we did it till question 25. Open your booklets. Let's move on. Question 26. In the periodic table, the p block contains elements whose outer electrons are found in the p subshell. Oh my god, we didn't know that, examiner? We already know that, you dumbo. Okay, elements in the p block show a general increase in the first ionization energy as the atomic number increases. Okay, that would show a general increase in first ionization energy across the period. We know that's going to happen. Now, draw the shape of the p orbital. Here you go. That's the p orbital. You can draw it like this. You can draw it like sorry yaar, I'm just gonna drink a glass of water. Let me pause this. You can draw it like this, you can draw it like this, however you want, vertically, horizontally, in the y-axis. It's up to you. Just give me a second, let me drink a glass of water. Now I drank a glass of water. Let's continue. Write the equation to show the first ionization energy of silicon. What is the first ionization energy? How do you define it? It's the energy required to remove 1 mole of electrons from 1 mole of gaseous atoms to give you 1 mole of positive ions, Si gaseous and positive obviously, and that I've removed 1 mole of electrons. So what's going to be the equation? Si gaseous state goes from Si gas to Si positive gaseous state, and by the removal of 1 mole. Remember always to write the charge on the electron. Just like you're writing the charge on the positive ions, always write the charge on the electron. Explain why there's a general increase. Don't talk about the exceptions. Just tell me why there's a general increase in the first ionization energy or energies of the elements across period 3. Again, what happens across period 3? Well, there's an increase in nuclear charge, and there's the shielding almost remains constant. So the shielding is almost constant. Shielding is almost constant, and therefore the effective nuclear charge increases, and thus there is stronger attraction for the outermost electron, for the valence electron by the nucleus obviously, and therefore for the valence electrons or electron, and therefore what's going to happen? What's going to happen? The ionization energies are going to increase. That's it. Easy. Next. Element A is in the p block. Okay. The graph shows the successive ionization energy for the removal of the first 10 electrons. Okay, I'm removing the first 10 electrons of A. State and explain the group of the periodic table that element A belongs to. Now look at this beautiful element A. It's in period 3, and he just wants you to tell me the group number. Let's add the periodic table here just for more visualization. Yeah, just add periodic. So he's told me that it's in period 3, so it's in somewhere here. Now I just need to understand which group it's in, Now look at this. Ionization energy, successive ionization energies always increase. Why? Because first of all, you understand that it's a more positively charged ion, which results in fewer electrons for the same number of protons, and therefore stronger attraction for the outermost electron. And it's a smaller ion, so again stronger attraction for the outermost electron. But when there's a large jump, you know that the principal quantum number has changed. So see, these threes are this is an increase in ionization energy and an increase in ionization energy, but it's not a large jump. You see a large jump here between the third ionization energy and the fourth ionization energy, which means that the first 3 electrons right here, these fellas, they must have been removed from the outermost shell. And the fourth electron, why is the ionization energy higher? Because the fourth electron is removed from a shell closer to the nucleus. The nucleus. That's why that is indicative of the fact that there are only 3 electrons in the outermost shell. Easy peasy, lemon squeezy. So it must be if 3 electrons in outermost shell, it must be in group 3, or the better terminology now is group 13. And we also know what element it is. So if it's in period 3, group 13, that element is aluminum right here. So what's the explanation? Well, the explanation is pretty simple. There's a large jump between the fourth ionization energy and the third and the fourth ionization. Yes, the third and fourth ionization energy, which means that fourth electron is removed from shell closer to the nucleus, and thus therefore indicative of the fact that there are 3 electrons in the outermost shell. That there are 3 electrons in outermost shell. Khatam? It's beautiful explanations, yaar. I'm writing very beautiful explanations. Yes, large ki jagah it's better to write larger jump, or it's a larger jump or bigger jump, write it in comparative form. Vanya, not 3, write group 13. It's okay if you write group 3, it doesn't really matter, but again, I always say stay on the safer side. So in the periodic table, if it's calling it group 13, call it group 13. It's written right here. Group 13, group 3 was the same thing. In A levels, they've just called these vertical columns as groups also. Nobody cares. They aren't in fact groups. Okay. Silicon is found in many compounds in the Earth's crust. Silicon has only 3 naturally occurring isotopes: silicon 28, 29, 30. The table shows the data of 28, 29, and 30. A sample of silicon contains, this is a good question. It will check your mathematics. A sample of silicon contains 92.2% of Si28. The total percentage abundance of Si29 and Si30 is 7.8. So these two combined is 7.8%. Now it says the relative atomic mass of silicon in the sample is 28.09. Calculate the percentage abundance of Si30. Now this is a beautiful question. So he's not giving you the individual abundances. He's only given you the individual abundance of Si28, but not of 29 and not of 30. What do? Pretty simple. I know that the Si28 has the isotopic mass of 28.0 multiplied by its abundance 92.2%. And then I don't know this abundance right here. So can I call it X? I don't know this abundance right here. I don't know the abundance of Si29. I'll call it X. It's fine. What is going to be the abundance of Si30? Go on. Let's see whether you can do it. What will be the abundance of Si30? If the total abundance, if I'm saying in total you have 7.8 toffees, and here you have 2 toffees. How many toffees do you have here? You'll say 5.8. How did you get with 5.8? See, it's pretty easy. Look, if I say you have 7.8 toffees in total, yeah? And let's suppose I say you have 2 toffees here. Let's suppose these are 2 toffees. So how many toffees would be here? You would say, sir, it's 5.8. How did you end up with 5.8? You ended up with 5.8 by taking 7.8 and subtracting 2 from it, right? So if I'm saying you have 7.8 toffees and 2 are these, then this is 5.8 because you took 7.8 and subtracted 2. What if I say now you have X toffees? I don't know how many toffees you have. So it's going to be 7.8 minus X. So if one is X, the other one should be the total number of toffees minus X, 7.8 minus X. Pretty simple. Not 100 minus X, Vanya. That's the most common mistake. Because 100 is the overall abundance. These two combined is 7.8. See, you just have to look at these two. You're not going to say 100 minus X. Don't rote learn things. It's not 100. That's the most common mistake that students made here. Because if this is X, this should be 100 minus X only if these are the only 2 isotopes. Here you also have a third, and that isotope has the percentage, which is 92.8. So these two combined would only have 7.8%. And out of this 7.8, if this is X, this should be 7.8 minus X, not 100 minus X, Vanya. Make sense? So it's going to be what? 29 times X plus 30.0 times 7.8 minus X. And O divided by the total abundance, which is 100, 92.2 plus 7.8, and that will give me the AR, which is 28.09. So love this mathematics. Love it. Love it, sir. I'll also write O levels here on top. So I would someday teach this in O levels as well. Although such difficulty may not be required, but I'm writing O levels here so that they can also be mathematically sound. Okay, what do we get? Can somebody calculate it for me? So 28 times 92.2, that gives me 2581.6 plus 29x plus 30 into 7.8, that gives me 234 plus minus 30x, and this 100 I'll multiply it there, so it's equal to 2809. Done. Now 29x and minus 30x, that gives me minus x. Good stuff. Equals 2809 minus 234 and minus 2581.6. I've taken this on the right and this on the right. What do I get? 234 to minus 1 minus 2581.6, and then add this to 2809. You get minus 6.6. So minus x equals minus 6.6. 6 cuts, minus cuts, you get x equals 6.6. Now that's the answer of x. And x is what you called silicon-29 isotopes abundance as x. So this is 6.6%. Now it's asking you the abundance of silicon-30. So what's the abundance of silicon-30? Well, the total is 7.8. So silicon-30 should be 7.8 minus 6.6. That gives me what? 8 plus, 7.8, 6.6, 1.2. 1.2. That's it. It's literal mathematics. It did not have anything to do with chemistry. Nothing. Nothing whatsoever. So it's 1.2%. Easy, guys? Pretty easy, huh? Conceptual understanding is important, not rote learning. Please read the questions carefully. Time question pe lagaye. Group 2. Elements share some common chemical properties. Okay. Calcium reacts in cold water more quickly than magnesium because, see, he's going to give you, don't get startled. We say when we are performing audits of these large, big multinational companies, we always tell each other, tuttle nahi hona. Tuttle means don't get, scared by just looking at this big data. Don't get scared. Don't get scared by extra information. Sometimes the examiner is going to talk about coffee being made. Sometimes, even mostly in organic chemistry, when you study organic chemistry, you will love the questions there. They actually introduce you to real life problems and real life situations. So enjoy it, read it, enjoy the question. So it's saying calcium reacts with cold water more quickly than magnesium. Oh my God, awesome, that's good. I have more information. Okay, that's really what's happening. Okay, good stuff. And he's also telling you the reason, because more energy is required to remove the outer electrons in magnesium, which means magnesium has a higher ionization energy. Now, see, you're enjoying the question and also slowly deducing why it should be the case. So if you look at magnesium and if you look at calcium, obviously magnesium has a higher ionization energy. Why? Calcium is down the group. So magnesium has one fewer shell, one fewer inner electron shell. And if it has one fewer inner electron shell, obviously there's going to be less shielding. And less shielding means stronger attraction. Stronger, the outermost electron is going to be attracted more strongly. Yes, because if there's one fewer shell, the distance is also less and the shielding is also less. So stronger attraction. That's it. That's what you need to do with your brainerino. Yeah. So he's saying required to remove one outer. This occurs even though calcium has a greater nuclear charge. See, the examiner is confused. He's saying even though calcium has a greater nuclear charge, why is this the case? Explain why this is the case. Because magnesium has one fewer electron shell, inner electron shell obviously, one fewer inner electron shell versus calcium, which is how many shells does magnesium have? Magnesium has 3 shells, it's in period 3, calcium has 4 shells. So I'll also tell the examiner, 3 shells and 4 shells respectively. Respectively means the ones that I've written first, that comes first. So respectively. Okay, good stuff. What about it then? And therefore this results in less shielding, S-H-I-E-L-D, yes, results in less shielding, and the valence electron is also closer in Mg, is also closer to the nucleus. Therefore stronger attraction for the valence electron of magnesium. And please understand that my explanations are going to be far more detailed than what's required, what the marking scheme says. Because especially in A levels, the marking scheme is made for teachers, not for students. Marking scheme should have the key phrases there, but please understand, less shielding effect. Yes, less shielding effect. Less shielding effect. Shielding keh rahe hain, shielding effect keh rahe hain, same thing. Less shielding effect. Happy? So realize that the marking scheme is mostly made for teachers in A levels. You know, for you guys, the explanation is, even if the marking scheme only has 2 phrases, you're not going to write 2 phrases. You're going to write what I am writing. That's the entire purpose of solving every question with you guys. So look at the linkage. Taimur is saying easy peasy, lemon squeezy. You know, that's what happens. Is there anything else I can write here? Yes, you could also say, hey, examiner, I'll also add something else. I'll say, hey, since you've mentioned that, you know, even though calcium has a greater nuclear charge, I'll tell you that this, which outweighs the increase in nuclear charge, right here. I'll add this right here. So it is closer to the nucleus. Therefore, right here, I'll add this right here. I'll put a steric here and put a steric here. Therefore, outweighs the increase in the higher nuclear charge of calcium. See, I've also finished the examiner's confusion, because the examiner was confused that even though calcium has a high nuclear charge, what's the case? So I told him, hey, it has a high nuclear charge, but realize magnesium has 1 fewer shell, and the distance between the outermost electron and the nucleus of magnesium obviously then is less. It's less. There's a smaller distance, and because of that, the outermost electron is strongly attracted by the nucleus. And therefore, this outweighs the factor of increased nuclear charge. That's it. I've clarified all the questions. Sir, can we also do some Edexcel past paper questions? No, don't do Edexcel past paper questions. Your questions are far more superior than Edexcel past paper. Edexcel questions are very simple, very straightforward. Cambridge questions have a little twisty and turnies. So Cambridge questions are more. That's why, you know, especially students who are doing Edexcel, obviously their course is a little different, but those who are doing Edexcel and they practice Cambridge topicals simultaneously, and then they do topicals as per their own syllabus, they normally get A stars and whatnot, but they also have to look into their own syllabus, because there are certain factors and certain points which are in their syllabus and not in Cambridge. But there's a lot of Cambridge content that may not be in Edexcel or AQA, because Cambridge length of the syllabus is pretty extensive, and it's just fazul mein. I don't like it. I don't like the length. It's too much. So we've seen Edexcel students get distinctions in prior years, and they studied from teachers who were teaching solely the Cambridge course. So that's one advantage. Edexcel is easy, because in Edexcel, the beauty of Edexcel is that if you have 3 components and you get one bad component, you can reappear for just a single component instead of reappearing for all 3 components. But Cambridge, I think, will give you more edge over Edexcel students when it comes to length of. Every board has their pros and cons. Dafa kare, just focus on questions. Construct an equation for the second ionization energy of argon. So what's the second ionization? Argon. If it were second ionization energy, means that argon is now going to make a 2+ gaseous ion, right? So in order to make a 2+ gaseous ion by removing 1 mole, you need to remove it from a 1+ gaseous ion. So a 1+ gaseous ion is going to be there, and you're going to have a 2+ gaseous ion by removing 1 mole of electrons. Because ionization energy does one step at a time, removes 1 mole, 1 mole, 1 mole, 1 mole, 1 mole at a time. A lot of students do this. They do this. They say, hey, argon gaseous atom, and then you get argon 2+ gaseous atom by losing 2 moles of electrons. That's wrong. That's not what ionization energy is. Ionization energy always talks from the perspective of 1 mole. You first remove 1 mole, then the other, then the other, then the other. So the idea of this equation is absolutely incorrect. I'll also remove it, so those who just look at the PDFs don't get confused. Next, the graph shows successive ionization energies for the element of argon. Complete the graph with predictions. Okay, he just wants to test our predictions. For the 8th and 9th ionization energies of argon, use a cross for each data point. So 8th and 9th ionization energy. It's a pretty beautiful question. Now see, argon has 8 electrons in its outermost shell. Everybody agrees, right? 8 electrons. It's in group 8, so 8 electrons need to be removed. Now, He's removing the first, the second, the third, the fourth, the fifth, the sixth, the seventh. Okay, 7 electrons are removed, good stuff. Now, when he removes the 8 electron, that's also going to be good stuff because all the 8 electrons will be removed from the same shell. 3, 4, 5, 6, 7, 8, right? So he's removed this, he's removed this, he's removed this, 3, 4, 5, 6, 7, and the 8th I'm removing. So the 8th ionization energy should not be a very big jump because it's from the same shell. So I'll write the 8th ionization energy somewhere around, 15,000 or 15,000. 16,000 doesn't really make it. The examiner gives you a range. I think in this question, the range for the 8th ionization was from 13,000 to around 20,000. So it's a huge range. He's giving you a huge margin here. And then when you remove the 9th electron, so the 9th electron is going to be removed from a shell closer to the nucleus. And so therefore, there's going to be a larger jump between the 8th and 9th ionization energy. And what we need to understand is that if he's given me the 10th ionization energy, which is somewhere around 45,000, the 9th ionization energy should be closer. The 9th ionization energy, let's suppose, should be around, it should be a big jump, not like 40,000 or something, but like a little here, somewhere in the middle. So a big jump, a larger jump. I'll add it here. So that's my prediction. I think for this, the jump, the value that he gives you is around, I think I should also go a little higher, a little close. If you see their jumps, it's around, if this is 5,000, 6,000, if this is 6,000, this is around 8, 9,000, So if this is 45,000, I'll go like, around 8,000 lower than this or 9,000 lower than this, maximum, or 5,000 lower than this. No, not 8,000, sorry. This is 5,000 and this is 6,000 and this is 7, 8. There's only a 2,000 gap. There's only a 2,000 ionization energy gap. So I'll go 3,000 below this. So probably somewhere the 9th ionization energy should probably be somewhere like here. I'll go like 5,000, 4,000 behind it. And the marking scheme would probably give you, for this, the range is going to be probably around a 10,000 range. So around 35,000 to 45,000, all would be correct. So that's the 9th ionization energy. There's going to be a large jump, because see, the 10th, if it's closer to 45, I'll just go 3,000 below it, because realize all of these are about 3,000, 3,000, 3,000, 3,000, 3,000 below it. So yeah, that's it. 2 marks, easy. The energy value required to remove the first electron from an atom of argon is circled on the graph. Okay, it's circled on a graph. Sketch the shape of the orbital that contains this electron. What's going to be the shape? Now, argon is in the p block. Right here. Let me even show it to you. Argon is right here in the p block. Its outermost electron is what? 3p6. It's in the p orbital. So what should be the shape? Everybody? What should be the shape? Make sure to draw the orbitals a little beautiful, a little more accuracy, with a little more accuracy. Something like, oh my God, the way you could draw this is like this. Put a dot and then, like this and like this. And make sure these two lobes are the same. Examiner is very particular about them. Don't just waste time on this, but, something like this. That's the best drawing I could draw. You could also draw it horizontally, yes. Horizontal drawing, my horizontal drawing is pathetic. Yes, now it's fine. Either this, or you could draw it in another way, but the better is either draw it horizontally or completely vertically. Normally, the examiner normally draws it's vertically. Now, a sample contains 3 different types of atom: argon, potassium, and calcium. State fully in terms of numbers of subatomic particles, what these 3 atoms have in common. So if you look at this has 40 nucleon number, 40 nucleon number, 40 nucleon number. So in terms of subatomic, all have the same nucleon number, which is 40. Or you could have said, if you said, hey sir, nucleon means the total number of protons plus neutrons, and he said subatomic particles in particular. So can I not say that all have, or you could say that all have the same number. Nucleon is the same, protons plus neutrons, but if you want, they could say all have the same number of protons plus neutrons. That is 40. So you could have also said that. That's also fine. It's fine. That's absolutely correct, Reno. Khadam. Same number of protons plus neutrons. Yes. Same sum, same number, same sum keh dein, same sum of protons. Bas khush. Same sum. Sum is better because if you just say same number of protons plus neutrons, the examiner may think you're just wrong about the number of protons, but they are not same. So same sum of protons plus neutrons. If you say they all have the same mass number, 0 mark. 0 mark. Mass number is not a representative of subatomic particles. Subatomic particles means protons, neutrons, electrons. That's it. Done? Statefully. I love this question. See, those who wrote learn A levels, they are cooked. Those who think that A levels is all about past papers, they are cooked. Your theoretical knowledge and understanding should be up to mark. Now listen to this question carefully. Let me just change this. I'd like to use what was this called? A Star Wars what? What's this called? A cyber sword? I forgot the name. Oh my god, I used to watch Star Wars and now I forgot. What is this called, guys? Anybody know? Something from S. Somebody's written something. Lightsaber. See, I saw it as a saber. So statefully in terms of what is written. What is written? Aanke part ke. Look at it. All subatomic particles. All subatomic particles. All subatomic particles. How these three atoms differ from each other. Now those who think, oh my god, they have different number of protons. Okay, I'm going to write different number of protons. Do you think they're going to get marks? Do you think they're going to get marks? It's all about a lightsaber, yes. Do you think they're going to get marks? I have a question. Do you think they're going to get marks? See, it's correct. One is 18 protons, one is 19, one is 20. So, all have different number of protons. Should I get a mark or no? See, my goal here is to teach you how to read questions. Anji, bataye, shabash, jaldi, be quick. Should I get all the marks? Should I get this 1 mark or no? Am I deserving or no? Be quick, everybody. Be quick. No, why shouldn't I get these marks? Because tell me all subatomic particles, their protons are different, therefore their electrons are also different, and because their protons are different, the neutrons 40 minus 18 minus 90 19 minus 20, and even the neutrons are different. Then students say, where did my marks go? It went here by not reading the question. So they have different number of protons, electrons, and neutrons. Yeah? Okay. A sample of sulfur contains two isotopes, S32 and S34. The relative atomic mass of this sample is 32.09. Calculate the percentage abundance of these isotopes present in the sample. So I know the isotopic masses, but I don't know the abundance. So if this is X, now in this case, Vanya, I can say this is 100 minus X because the total percentage is always 100. So if this is X, that's 100 minus X. For the above situation, why didn't I say 100? Why didn't I use 100 here? Because 92.2 was already known for this. Yes, the total is 100, but this is already known. So between these two combined was 7.8. So if this is X, then this would be 7.8 minus X. Yeah, pretty straightforward. Mathematics. Yeah, mathematics. So it's going to be what? 32 times X plus 34 times 100 minus X divided by the total percentage abundance, which is 100, equals to the relative atomic mass. What's the relative atomic mass? He must have given it to us, 32.09. It's going to be 32x plus 3400 minus 34x equals, I'll just multiply this on the right, so 3209, and then minus 2x. Why minus 2x? Because 32x minus 34x gives me minus 2x. And I will subtract by minus 30, I'll subtract 3400 on both sides, so this will be 3209 minus 3400. What do I get? Minus 2x equals 3209 minus 3400 minus 191. Minus cancels out. X is equal to 191 divided by 2. What do I get? So that gives me what? Can somebody do it? 95.5? So X is 95.5% right here. What was X? It was sulfur 32. So sulfur 32 is 95.5%. What's sulfur 34? It's 100 minus 95.5. Please write the steps for yourself. So that gives me what? 4.5 if I'm not wrong. 4.5. 3 marks for nothing. 3 marks for doing nothing. For doing nothing. 3 marks for doing nothing. I'm not even joking when I say it's nothing. What did you do here? 3 marks took you 1 minute. No, not even 1 minute. 40 seconds. You think A levels is difficult? I'll prove it. It's not. The electronic configuration of sulfur in an atom is blah blah blah. Identify which orbital in a sulfur atom has the lowest energy. The orbital. Which orbital has the lowest energy? If you just say the s orbital, that's wrong. Which orbital? Is it the 1s, the 2s, the 3s? Which one? It's the 1s. That has the lowest energy. So when it talks about orbital, you talk about the orbital. Sir, just 3 minutes left. Chillax, chillax. Sketch the shape of the p orbital. Ooh, Sir Suleiman with the drawing. Let's go, let's go, let's go. Okay. During the process of ionization a sulfur atom loses an electron. Identify the orbital from which this electron is removed. Explain your answer. So he's also even giving you the electronic configuration of sulfur. It's 1s2, 2s2, 2p6, 3s2, and 3p4. Where would the electron be lost from? Which orbital? It's the p orbital. Ain't that true? Which p? The 3p. So explain it. It's the 3p orbital. The 3p orbital. And what's the explanation for it? Because the 3p orbital is the orbital which has the highest energy. So electrons are lost from the highest energy orbitals first. So the 3p orbital is at the highest energy, not a high energy, is at the highest energy, or it's the highest energy orbital. You could say it's at the highest energy, or the 3p orbital is the highest. That's better. Is the highest energy orbital, and thus is furthest from the nucleus. And yeah, that's it. Therefore electron is removed from it. Please understand that the marking scheme may not have such detailed answer, but you have to write these detailed answers. It doesn't matter if you go below the line. Wait, what's going on? Did I miss something? Yes, Safa, you missed practice questions. Complete the diagram to show the arrangement of electrons within the third shell of a phosphorus atom. The third shell, which means principal quantum number 3 of phosphorus atom. Let's check it out. Just check the periodic table. I can't be bothered. So let's just add the periodic table. This is principal quantum number 3. So principal quantum number 3 is right here. This is 3s2 and this is 3s2 and 3p1, 2, 3. So 3s2, 3p3. It's 3s2, 3p1, 2, 3. Happy? Done. Explain why the first ionization energy of sulfur is less than that of phosphorus. Why? Now you'll tell the examiner that even though I acknowledge the fact that sulfur has a higher nuclear charge, the higher nuclear charge is outweighed by the spin pair repulsion in one of its 3p orbital. Like we've done this question a billion times. This is phosphorus and that is, my dear fellas, sulfur. So even though sulfur has a higher nuclear charge, the higher nuclear charge is outweighed by the fact that it has 2 electrons in one of its 3p orbital, and therefore it has a lower ionization energy. So although sulfur has a higher nuclear charge, but this is outweighed by spin pair repulsion of electrons, in one of the 3p orbitals of sulfur, which contains 2 or which has 2 electrons. Yeah. So see, my English might differ from place to place, but the idea is true. Sir, then why in comparison of d filling electrons, why is the 4s d-filled instead of the 3d, even though the energy... Manur, I have explained this in the live class. It's a good question. I have explained this in the live class, that what happens is once the 3d and the 4s are filled, the 4s goes at a higher energy level. But what you needed to know was a shortcut, which was always de-fill from the highest principal quantum number first and do reverse of filling. So go reverse of filling, but always keep in mind you have to remove the higher principal quantum number first, electrons from the higher principal quantum number first, because once the 4s is at a lower energy than the 3d, but once the 4s and the 3d are filled, the 4s goes here. So then automatically the 4s is, that's why the 4s loses electrons first. That's the idea behind it. I have said that in the live classes, one of the live classes, I believe, when I was explaining this idea. Last question, question 30. State what is meant by the term relative formula mass. What's meant by the term relative formula mass? Now see, the term there are two terms. Please understand, this is O levels and IGCSE, and such a question is not asked anymore, but it's good. There's one term, relative molecular mass. Relative molecular mass. What was relative molecular mass? What was relative molecular mass? This term, which was MR, this term was usually used for what? It was used for molecules. Now, if you have ionic compounds like NaCl, or like maybe calcium chloride or whatever, right? If you have ionic compounds, the term relative molecular mass becomes a little too vague for it, because it's for molecules. Relative molecular mass was what? The mass of a molecule, the average mass of a molecule compared to 1/12 of a carbon atom, where carbon is exactly 12 units. That was relative molecular mass, right? But when you have sodium chloride or calcium chloride, then calling it relative molecular mass becomes a little skeptical. You should become a little skeptical. That's why scientists came up with a term called relative formula mass, because formula mass is a broader term. You can use the term relative formula mass for ionic compounds as well as for covalent, simple covalent molecules or whatever. So if you have HCl, you can also call its relative molecular mass as relative formula mass, and calcium chloride, you should call this as relative formula mass. The calculation is the same. You calculate it the same way. Hydrogen is 1, chlorine is 35.5, so the relative molecular mass is 36.5 or the relative formula mass is 36.5. Again, just like for sodium, that's 23, that's 35.5. So the relative, you add them, it's the sum of ARs. So the relative formula mass is 58.5, or you could say relative molecular mass is 58.5, but the term molecular mass here is a little skeptical, although even in the exam they will use it interchangeably. But the reality is that for ionic compounds in particular, the term relative formula mass should be used, because relative formula mass is the mass, it is the mass of, remember, see, it's the mass of all the atoms. It can be the mass of all the atoms or all the ions. It is the mass of all the atoms or all the ions. And not just the mass, the weighted average mass. It's the weighted, just like you write relative atomic mass is definition. So it's the weighted average mass of what? Well, formula mass has ions as well and atoms as well. So it's the weighted average mass of all the atoms and ions. Yeah, all the atoms and ions, and you call this one unit as a formula unit. So this is like a formula unit, a formula. These are just scientific and technical terms used for it. So this is considered as one formula unit, a formula unit. So a formula unit contains either ions or atoms. So you say the weighted average mass of all the atoms or ions. All the atoms / ions in what? In a formula unit. Such a definition is not asked anymore, but hey. In a formula unit, and then obviously because it's relative, therefore we say compared to 1/12 of a carbon atom, 1/12 of a carbon atom, where carbon is exactly, or carbon 12 atom, 1/12 of a carbon 12 atom, where carbon is exactly 12 units. Done. Easy. So I haven't taught relative formula mass definition to you guys, but it came up in the past paper, so I was like, okay, because now it's no longer a part of your syllabus. I haven't seen defined relative formula mass in the syllabus. I don't think I've seen it. I'll go through over the syllabus. I think it may be written in moles and stoichiometry, maybe. Let's check it. Let's check it. But that's it. Question 30 tak bas hai. Question 30 bus. The total number of questions are 55. They're not actually 55, they're actually 56, but we've misprinted one number. Done, bus? Or do you want to do more? Do you want to do more? Maza aa raha hai ab. Let's check the syllabus for a moment. Yeah. So I've added the syllabus. Let's check it out if the definition of relative formula mass is there. Even if it's, see, when I teach you guys, I highlight these things. This is my syllabus. When I teach you guys stuff, I highlight it, that I've taught students this, I've taught students this. So I stick very, very, very closely to the syllabus. These have not been yet highlighted. I am yet to highlight them. I've taught you guys this. See, define relative atomic mass, relative isotopic mass, relative molecular mass and relative formula mass in terms of unified atomic mass unit. Okay, that's done. Okay, fine. So that's that. You could also define it in terms of unified atomic mass unit. The examiner can ask you this. Unified atomic mass unit we've already defined, because you know that unified atomic mass unit is the mass of 1/12 of a carbon 12 atom. We've defined it in the past papers, in the prior past papers. So let's suppose I were to define this in terms, if they say what is meant by the term relative formula mass, I can also define it as the weighted average mass of all the atoms / ions in a formula unit. Instead of saying compared to 1/12, compared to the mass. Compared to the mass of 1/12 of a carbon 12 atom. So instead of saying compared to the mass of 1/12 of a carbon 12 atom, where carbon is exactly 12 units, this entire term can be replaced by compared to the mass of, or you could say compared to the mass of, or just compared to unified atomic, compared to AMU, or you would also call it Dalton. So compared to the unified atomic mass unit, because unified atomic mass unit means what? The mass of 1/12 of a carbon 12 atom, where carbon is exactly 12 units. That's what it means. And we've done this in the prior past paper. So you should know the definition of relative formula mass as well as relative molecular mass, the one that I've taught, the weighted average mass. Don't write sum of the relative atomic masses. That was just O levels. Sorry. So that's it, guys. Any questions?